Good morning YouTube, I hope everybody is doing well. We're back at it again in quadratics, and this time we're looking at the quadratic formula. Now before we jump into the quadratic formula and using it, I thought it might be fun to see where the quadratic formula comes from. So what we're going to do is we're going to spend about 5 minutes just explaining the quadratic formula and how it's derived. If you would prefer to jump straight to knowing what the quadratic formula is and how to use it, I'll leave a little timestamp below. But let's just jump into exploring where the quadratic formula comes from. For context, I haven't actually said, the quadratic formula allows us to solve any quadratic equation which has solutions. If there are no solutions, you can't find solutions that don't exist. Things that don't exist can't be found. Let's have a look at this. So let's see where the quadratic formula comes from. In a previous video, we looked at these two shapes. We've got x as the height and x and then b as the breadth here. And the area, the highlighted area of this shape on the left-hand side is height times depth, which is x multiplied by x plus b. Now what we did a little bit of surgery. We cut half of this light blue shape and we stuck it on the top instead. And looking at the area of this new shape, we had the same quantity expressed in a very different way. So I had x plus b over 2 squared, that's height times depth, that's x plus b over 2 would be this length, x plus b over 2 is this length. We square it to get the area, but we have to just correct a little bit by taking away this b over 2 squared. We have to take away this extra area that we've added on there. And last lesson we did some maths-arino, and we saw if we expand the left-hand side, we get x squared plus bx. If we expand the right-hand side, we get x squared plus bx. And we arrived at this fundamental truth about the universe, which is x squared plus tx equals x plus t over 2 squared minus t over 2 squared. I've just swapped b for t. It's the same equation. I'm just doing that for clarity, and you'll see why in just a second. So here is the generic form of a quadratic equation. It has some quantity a of x squared, some quantity b of x, and some quantity c of some constant. Any of these could be 0 other than a. If a is 0, it's not really a quadratic. What we are going to do, and the adventure we are going to take to prove the quadratic formula is, are you ready? We are going to complete the square on this generic form of a quadratic equation. Ooh, fun. Let's jump in. So the first step towards completing the square is I'm going to factorise out a from these first two terms. So in this little bracket it's going to be x squared plus b over ax. I've made no change to the quantity here. If I expand this back out, I have ax squared plus bx. Now, all I'm going to do is I'm going to ignore everything else and I'm just going to concern myself with what's in this bracket, okay? I'm going to take what's in this bracket, I've rewritten it here, and I'm just going to complete the square on this form here. Okay, so I know, completing the square, if I have x squared plus tx, that is the same as x plus t over 2 squared minus t over 2 squared. Now in this case, t equals b over a. Okay, so all I'm going to do is rewrite this, which is in the correct form, x squared plus tx, and I'm going to write it in the completed square form. So this will now equal x plus b over 2a minus b over 2a squared. So I've rewritten what was in this bracket, which I've highlighted in yellow, and all I'm going to do now is I'm going to reinsert this into my full equation. So my full equation is now, after I've completed the square, is x plus b over 2a squared minus b over 2a squared. Okay, right, completing the square is done. All we're going to do now is we're going to solve this equation for x. You'll notice there's only one x now, which is lovely. And we're going to solve for it. So let's do some algebra. Algebra, let's get it. That was a dab, by the way. You're welcome. So, first thing I'm going to do is I'm going to take c away from both sides. So I have a brackets x plus b over 2a squared minus b over 2a squared equals minus c. I'm going to divide both sides by a, so I have x plus b over 2a squared minus b over 2a squared equals minus c over a. I'm going to add b squared plus 2a to both sides, so I have x plus b over 2a squared equals b over 2a squared minus c over a. Now what I'm going to do is I'm going to do some algebra to the right hand side. We're just going to make that look a little bit more nice. So I'm going to say x plus b over 2a squared equals b squared over 4a squared minus c over a. This stays the same on this side. What I'm going to do is I'm just going to make a common denominator to smush these two terms on the right hand side together. So I'm going to say this is the same as b squared over 4a squared minus 4ac over 4a squared. So what I did was there is I multiplied top and bottom of that second fraction by 4a, and this allowed me to write the same denominator as is in the term b squared over 4a squared. So combining those two terms, I have x plus b over 2a squared equals b squared minus 4ac over 4a squared. Okay, now what I'm going to do, I'm going to take the square root of both sides. If I take the square root of both sides, on the left I just have x plus b over 2a equals plus or minus, because it's square root, b squared minus 4ac over 4a squared. Now, when I have a square root, I can separate the numerator and the denominator like so. This is equivalent to x plus b over 2a equals plus or minus root b squared minus, auto draw, had an idea there, b squared minus 4ac over square root 4a squared. Now, the square root of 4a squared is known. This is 2a, so I have x plus b over 2a equals plus or minus root b squared minus 4ac all over 2a. I'm going to take, spoiler alert, I'm going to take b over 2a away from both sides, so I have x equals minus b over 2a plus or minus the square root b squared minus 4ac over 2a. Last step, I'm going to combine those two fractions together, and I have x equals minus b plus or minus the square root b squared minus 4ac over 2a. Ta-da! You might recognise this as an old friend. See, this right here is the quadratic formula, and now you know where it comes from. We complete the square for a generic quadratic, and then we solve for x. And here it is in all of its glory. So if I have any generic quadratic where I have a lots of x squared plus b lots of x plus some random constant c, and it doesn't matter what those are, if there are solutions, we can find them using this formula. We just take minus b plus or minus b squared minus 4ac over 2a. So using this formula is fairly straightforward. We're going to run through a few different examples. Essentially, you just want to get the quadratic, find a, find b, find c, substitute into the formula, crank the handle on the old algebra. You can use a calculator if that helps, and get your solutions. And they won't always be integers, they could be decimals or fractions or whatever. So enough wittering, let's just do it. Okay, so first things first, I'm the realist, stop, drop and let the whole world feel it. But after that, we're going to rearrange this and say 3x squared minus 16x plus 8 equals 0. This is in the correct form now. So I have ax squared plus bx plus c equals 0. By a comparison of the coefficients, I can say a equals 3, b equals negative 16, c equals 8. Okay, I'm going to take these bad boys right here and I'm going to put them into this quadratic formula. So I now can say that x equals minus b, which is minus 16, which is 16, plus or minus the square root 16 squared minus 4 multiplies 3 multiplies 8 over 2 times 3, which is 6. So it's just a question of algebra now. So x equals 16 plus or minus Let's just do that. 16 squared minus 4 times 3 times 8. So let's go straight into our calculator. So 16 squared minus 4 times 3 times 8 is 160. 160 over 6. So we've got an either or here. So x equals 16 plus root 160 over 6. Or 16 minus root 160 over 6. So excuse me, the second question is creeping in at the bottom there. So x equals, we'll just do that straight at the calculator. So 16 plus root 160 over 6. 16 plus square root 160 brackets divided by, divided by 6 is 4.77. I told you they wouldn't necessarily be nice roots. 4.77, or we'll just swap that to a minus bish bash bosh 0.558. So 0.558. 0.55. Oops, excuse me. 558. Generally on the A level you want to round to 3 sig figs. Did I do that right? 0.477. Yes, I did. Good. Okay, why don't you have a go at this one? Did it work? Did it not work? Try. Try again. And try again. Okay, we're back. So, ax squared plus bx plus c equals 0. By comparing my coefficients, I can see that a equals 2, b equals negative 3, c equals negative 18. Plugging these into my quadratic formula, I can say that x equals minus b, which is 3, plus or minus the square root of b squared, I'm just going to put that straight in as 9, minus 4 multiplies 2 multiplies negative 18, all over 2a, which is going to be 4. Okay, so let's get this junk under the square root sign sorted. So those two negatives multiplying will become a plus. So that's 9 plus 4 times 2 times 18. So 9 plus 4 times 2 times 18. 153. 4 times 2 times 18, yeah. So that's 3 plus or minus, gosh, I've already forgotten, short-term memory, 153. Square root 153 over 4. So x equals this, so either x equals 3 plus root 153 over 4, or x equals 3 minus 153 over 4. Let's just do it. 3 plus root 153, bam, divide by 4, 3.84. 3.84, or let's go minus 2.34. If this is an intermediate step in solving a more complex mathematical problem, which will come up later in the A level, I would leave it in surd form for as long as you can to preserve accuracy and translate it into a decimal, perhaps right at the end. But for these purposes, we're going straight in with decimals. And I think I have, do I have? I do. I have one last example. So here's what I'm going to do. You can move it all to the left-hand side or all to the right-hand side. It really doesn't matter. I'll move everything to the right-hand side. So taking 2x squared from both sides, I have 3x squared. Taking 11x from both sides, I have minus 11x minus 18. So let me just write that the conventional way around. 3x squared minus 11x minus 18 equals 0. The generic form of a quadratic is ax squared plus bx plus c equals 0. By comparison of coefficients, I can say a equals 3, b equals negative 11, c equals negative 18. That implies that x equals minus b, so that's 11, plus or minus the square root 11 squared minus 4 multiplies, oh golly, 4, 3, negative 18. Wasn't it negative 18 in the last one? Negative 18 seems to be a popular choice. Over 2 times a, 2 times 3, 6. Okay, so that's going to be 11 squared plus 4 times 3 times 18 because of those two negatives. So let's just do that. 11 squared plus 4 times 3 times 18, 337. So I have x equals 11 plus root 337 over 6, or 11 minus square root 337 over 6. So, you know what, we're not going to do that last example. This will be the last one. So let's just bash that into a calculator. 11 plus root 337 divided by, what the hell was that? Divided by 6. 6, bosh, 4.89. X equals 4.89, or swap that bad boy for a minus, bish, bash, minus 1.23, 366, minus 1.23. Hopefully that helped. Yeah, quadratic formula, frankly, who even uses it? Because if you have a good calculator, your calculator can solve that quadratic formula for you. But it's a good one to know. Hopefully that helped. Smash like, follow my Instagram, subscribe, hit that bell, you know, all the good things. Peace.